Hey guys, let me know when it's actually up and running. Like, someone send me a chat post so I know that it's good to go. Hope it's not choppy. Oh my heavens. Harley, stop. Shoot. Sorry, that be my dog. Mm-hmm. 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 No. What's that? Harley, stop. All right, somebody post a chat or send a remind text so I know when the TV's hooked up. So I'll just teach from the screen. Hello? Yeah. Y'all didn't get it on remind? Okay. Hey, that's why I wrote on the stuff for somebody to hook so nobody can get it on their Chromebook at all? What? Everyone's always able. Okay, hey, here, give me, let me talk to Sarah. Stop, Harley. Yeah, Bernie. Did you seriously just have to ask? Hey, so Lauren was going to use one of the Talon laptops since they're not restricted. Can you just use that? Okay, yeah, just use that and hook up to the TV. And that should work. And then y'all will be able to ask questions. And because she was saying that y'all's Talon computers don't have the same kind of restrictions or anything. So yeah, if you can, do you have the link? Okay. Okay, and then you should have the same, like, you just need an HDMI cord to hook up to the TV. So those cords are just sitting there on my desk. Okay. In. Harley. Yeah, so you can just pull a desk over there to my little desk and the HDMI cord. What do you don't have an HDMI port? You have a digital port? That'd be really crazy for you not to have an HDMI cord. No H. No HDMI or digital. Oh my heavens. Okay. Okay, let me just post on, somebody post the link on the board, like just write it on the board and everyone will just have to use their phones. All right, thanks. Bye. All right, so I only see like 5 on right now because you're getting on your phones. I was hoping I can't believe y'all's Chromebooks are restricting my live stream. That really actually annoys me. I'm going to send tech an email because that just annoys the crap out of me. I'm sending an email. All right. Y'all either comment or send me a remind so I know that y'all are like getting on. Okay, where you be at, people? Come on. Yes, or actually just go see if you can check out a Chromebook from her. All right, I need to know if y'all are able to see anything. Have your Chromebooks open to your notes as well. So you can just kind of follow along because we're looking at pyruvate as well as going into the Krebs cycle. So come on, come on, come on, come on, come on, come on. Alrighty, come on. Okay. All right, let me get my review out. When's the quiz? I told you the photosynthesis quiz is just online. It's already there. It's just a practice quiz. So, what is COA? That's what we're actually going to be looking at. So, if y'all want to try and follow along with your notes at the same time, good deal. Where's my Sharpie? Oh, there it is. Okay, So yesterday we looked at glycolysis. So you go from So you go from glucose being brought into the cell, and inside the cytoplasm, it goes through glycolysis. And the job of glycolysis is to break your 6 carbon molecule up into 3 carbon molecules called pyruvate. So you end up with 2 pyruvate molecules. Those pyruvate molecules then have a choice. They're either going to stay in the cytoplasm because they don't have oxygen, which we'll look at second, or they get to go into the mitochondria because they do have oxygen. And now you get to enter what is technically called the aerobic respiration of cellular respiration, right? This whole picture, this whole thing is cellular respiration. But this first part, glycolysis, that's actually anaerobic. There was no oxygen here in the cytoplasm. So we're going to first look at what happens if you do have oxygen and you actually do get to enter into the mitochondria. So the first thing that actually goes on, I'm going to kind of draw this. Right? So you have your mitochondria, you have an outer membrane, and then you have an inner membrane. That inner membrane is folded in on itself, creating 2 parts of the mitochondria, which you do need to know their names. So outer membrane versus inner membrane. That inner membrane has a very special name. We call it the cristae. And this open space in here is actually an aqueous environment, which kind of sounds like the cytoplasm, which technically it once was, if we're going according to the endosymbiotic theory that theorizes that the mitochondria used to be its own bacterial chromosome. So this aqueous space, we can't call the cytoplasm since cyto means cell, and this is no longer a cell. So we call that aqueous space the matrix. So what happens is, here's pyruvate hanging out, right, in the cytoplasm. Pyruvate then says, hey, I've got oxygen. I want to go in there. So to actually come into the cell, pyruvate, again, it's not a gas, so it doesn't get to just diffuse. It actually has to have assistance. So there's actually a transport protein that allows it and escorts it in. Now, as soon as pyruvate enters, go ahead and show you this. As soon as your pyruvate molecule enters, it's immediately going to be stripped of one of its carbons. Can you draw and explain the oxidative phosphorylation? Next. Yeah, we're not there yet, Megan. Hold on. Okay. So your pyruvate molecule, the 3 carbon molecule, as soon as it enters into the mitochondria, it's immediately going to be broken. So it's going to lose a CO2 molecule. Okay. So 1 carbon immediately gets broken. At the same time, it loses a hydrogen and helps create an NADH. And so what you end up getting left with is 2 carbons. So what used to be pyruvate, what is now pyruvate? My puppy is in there chewing on something. So look what happened. We lost a carbon. We lost a hydrogen. What does that kind of sound like? When you lose stuff, oxidation. So very specifically, this first step is called pyruvate oxidation. Okay, so we're going from glycolysis to pyruvate oxidation, and then we'll get into the Krebs cycle. Now, these 2 carbons, just like when we brought CO2, right? Just as soon as CO2 came into the stroma for the chloroplast, it had to be escorted. Same thing is happening here. These 2 CO2 molecules have to be escorted. That escort is combined by an enzyme called CoA. There, that's your CoA. CoA literally stands for coenzyme A. Its job is to add 1 carbon group to it, like an acetyl group. It's just grabbing those 2. So what we've created now is no longer pyruvate. We have created acetyl-CoA. These 2 carbons that are left over are literally called acetyl groups. That's what you call two carbons in chemistry. So acetyl-CoA. So pyruvate oxidation, I just marked it myself, gets rid of a CO2, gets rid of an NADH, and gets us acetyl-CoA. So this coenzyme A grabs the acetyl groups, escorts them in, and says, hey, I know where you need to go. And that is from this intermembrane space. The space inter means between, guys. So between the membrane space, that CoA then gets escorted into the matrix. That acetyl-CoA group. So what enters the matrix? Acetyl-CoA. What does not enter the matrix? Pyruvate. Little question there. Pyruvate never enters the matrix. It got fixed and oxidated here. So acetyl-CoA gets escorted, right? Or the acetyl group gets escorted into the matrix. And in the matrix, that's where we begin the Krebs cycle. Is it only used in Krebs? The CoA, that coenzyme A, its main job is just here in the Krebs. As far as its other properties, coenzyme A has evolved to have other jobs throughout other organisms, but as far as us, this is the only one you have to know. So that coenzyme A grabs, and now it's going to throw it into the Krebs cycle. So in the Krebs cycle, we're here in the matrix. So if I zoom into this aqueous, watery environment, I'm going to have an acetyl-CoA about to be thrown into a whirlwind. A cycle just like when we acted out the CO2. When the CO2 was grabbed by Rubisco, it was going to be thrown into the Calvin cycle. Acetyl-CoA is about to be thrown into the Krebs cycle. Okay, now that acetyl-CoA is actually going to be grabbed by not an enzyme here, but it's going to be grabbed because it already has an enzyme, that CoA. But it's going to help attach this 2-carbon acetyl group onto a 4-carbon group that is just always here floating in the matrix. Just like RUBP is just always there in the stroma, it's always regenerated. This 4-carbon molecule that it's about to be attached to is the same way. It's always there. And so this 4-carbon molecule is called oxyl acetate. Oxyl acetate. So these 4 carbons are floating around. This acetyl-CoA comes and gets attached to it. The CoA falls off. It goes back into the intermembrane space to do its job next. Remember, our cells are really great at recycling things. And so whenever we add these 2 carbons onto here, what we're essentially making is now a 6-carbon molecule that has a very specific name. The formation of this oxyl acetate, and when you add 2 more carbons to it, actually forms citrate. That's why the Krebs cycle is also called the citric acid cycle, because that's actually the first thing created as part of the Krebs cycle. So right here, you've got citrate or citric acid. That's the first thing that's been created. It's a 6-carbon molecule. But here's the purpose of the Krebs cycle. Okay? The Krebs cycle job is to throw out energy and release CO2. Just like the Calvin cycle was to take in CO2 and release glucose. Here, we originally, guys, started with glucose, and we're going to release it as CO2 in the Krebs cycle. So as we strip off our carbons, we release them as CO2. Those same carbons we just brought in from glucose originally, that's what we're going to strip off and release as CO2. So we're going to release those as CO2, and at the same time, as part of the Krebs cycle, as we oxidize, as we are oxidizing citrate, so we're removing electrons, we're removing hydrogens, okay? So here's our cycle. So the first citrate molecule, I'm going to kind of draw this guy out. So 6 carbons. We're actually going to remove those 2 that we just added from the acetyl-CoA and release them as carbon dioxide. Now, what we also did is we released hydrogens, which now allow us to create NADH, our energy-carrying molecule. Now, another enzyme comes and helps. You don't need to know all those names. Comes and helps and is going to reconfigure that oxyl acetate again, because he got changed when you added the 2 carbons. So as it gets reconfigured, we create ATP energy, and we create this guy, FADH2. Energy, energy, energy. They are all part of the energy family. They are just like ATP from photosynthesis. NADH is cell respiration. NADP, P as in photosynthesis, that's that energy carrier. But then we add this extra guy, FADH2, and he comes in very, very handy in just a second. Right? So we've ripped off those CO2s that we just used. We created energy, energy, energy. And ultimately, those 4 carbons of the oxyl acetate get recycled and go back through. They grab a CoA, acetyl-CoA, grab an acetyl-CoA, get added, create a citrate, rip them off, create energy, 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 and you do it all over again. Now, Bernie, the reason it takes 2 times per glucose is because what we start with from the very beginning, 2 pyruvates. 1 6-carbon glucose gets broken into 2 pyruvates. So 1 pyruvate goes in and becomes acetyl-CoA, goes through the Krebs cycle. The second pyruvate goes in, becomes acetyl-CoA, goes through the Krebs cycle. Okay, hold on. Somebody texted me too, so hold on. That's still just Megan's text. Okay. All right. That, guys, that really is. That's all that is the actual Krebs cycle. Like, bam. Now, I do want to point something else out. We mentioned it yesterday in glycolysis. In glycolysis, our job was to create ultimately 2 NADH, 4 ATP, but we had to recycle 2 back because we used 2 ATP. So you only net gain 2. Now, to create that ATP, we had to actually utilize another molecule that had phosphate on it. So we had to rip those off. So we call that substrate phosphorylation. Krebs cycle, these ATP are also substrate phosphorylation. These aren't being created by free-floating phosphates. They actually are attached to something. All right? So this is all that I need you to know for the actual Krebs cycle. This is it. Now, Megan, to kind of answer your question about oxidative phosphorylation, we're not quite there. That's tomorrow. That's the ETC. That's when we go from the matrix. We go from here where our Krebs cycle was happening, and we take that energy that we just made and we go here. We go into the inner membrane space. That inner membrane is called a cristae, right? That's where you're going to see oxidative phosphorylation. Oxidative is kind of equivalent to photophosphorylation. Photophosphorylation happens in the thylakoid membrane. Hydrogens flow through, and the hydrogens came from light breaking water. And then when hydrogens flow through the ATP synthase, ATP was made. Here, hydrogens are going to flow through again, ATP synthase, but they didn't come from light. They came from an oxidation reaction. So when you oxidize molecules, you release the hydrogens and they create ATP. But again, we'll talk about that very specifically tomorrow. We'll actually act it out too. Oh. Okay. The only other thing I just want to mention is what happens if you don't have oxygen, so you don't get to enter the mitochondria, you get stuck here in the cytoplasm. Guys, you go through this every time you go to work out too quickly. Not even too quickly. Anytime you go to work out, you're going through this. You can't avoid it. If we go into the mitochondria, you've entered what we call aerobic respiration. you've used oxygen. If you don't have it immediately available, you stay here in the cytoplasm and you're in anaerobic respiration. In this case, your cells will actually go through fermentation. So in this situation, what you actually get is, so inside the cell, we've had glucose get converted into pyruvate. That pyruvate now has to stay in the cytoplasm. And if you are an animal cell, you stick with what's called lactic acid fermentation. Hopefully some of this is kind of coming back a little bit. And so that pyruvate actually just, it just gets reconverted. It's still a 3-carbon molecule. This was pyruvate. That is not pyruvate. Pyruvate, not pyruvate. That's just your body's way of reconfiguring the molecules. But keep in mind, anytime you move atoms around in a molecule, you've created something else. So this was pyruvate. When you go through lactic acid fermentation inside your cytoplasm, what you create now is, well, lactic acid. It's just a 3-carbon molecule. Here's the reason we do this. You're like, well, if that's all we did, why'd we even do it? It has nothing to do with the fact that you made lactic acid. This actually sucks. This burns. This hurts. We hate it. Stretch before you work out. Stretch after you work out. Your coaches are telling you the truth. Stretching before gets blood flow. Blood flow brings oxygen, minimizes how long you have to stay in this, which means you minimize how much you make of this. Stretch afterwards, because you've made this, you want to get it moving through your body instead of staying concentrated in that one muscle, making you hate leg day the next day, right? So here's the thing. It has nothing to do with the fact that we created 3 carbons. Here's what happened. When we went from pyruvate to lactic acid, we had to use energy, which means I had to use NADH. So what I'm doing is recycling NAD so that NAD can come back up here to glycolysis and get made back to NADH. NAD back to NADH. Because at the end of glycolysis, guys, we made 2 NADHs and we made 4 ATPs. But to get that 4 ATP, we have to use NAD and pull hydrogens out. So the reason, evolutionarily speaking, we even have fermentation inside of our cells is because there are moments in time when our body doesn't have enough oxygen, but we still need ATP. It's not a lot. It's only 2, but at least it's ATP. So we ultimately, our purpose of fermentation is to recycle that NAD molecule so that it goes back to glycolysis and helps you make ATP. Again, I'll say that one more time. The reason fermentation exists is to recycle NAD to go back to glycolysis to make ATP. It doesn't matter what fermentation it is, okay? This is us, lactic acid. That's animals. If you are a bacteria or a fungus, you do the same thing. Glucose gets broken into pyruvate. But you do not stay 3 carbons. If you're a bacteria and you're going through fermentation, you actually go through alcoholic fermentation. Because those pyruvate 3 carbon actually go down to 2 carbon molecule because you release CO2. And that 2 carbon molecule is essentially just an alcohol. It has an hydroxyl on it. So in a bacteria, they go through this. They take pyruvate, release CO2, and make alcohol. They do this because this is their energy source when there isn't enough oxygen available to them. This is sourdough bread. This is beer. This can be wine. This can be just your regular bread that you're baking. Anything where you use bacteria or fungus and you're minimizing their oxygen availability, they're creating alcohol and releasing CO2. That's what makes bread rise. That's why bread has holes. Hole. Okay. You ever look at bread and you see a big hole and you're like, I'm feeling a little gypped on this, like all of a sudden you like lost half your piece of bread. That was just one huge CO2 bubble that just grew and grew and grew and grew while the bread was rising. And then while it got baked, it got released by the heat and you're left with a hole. I'm sorry, right? Can you show the pic a little closer? It's hard to read. I'm sorry, Georgia. Okay. Can we get a rundown of the respiration quiz? It says we have one tomorrow on the board. Guys, just like I said yesterday, I made an online practice quiz for photosynthesis yesterday. It's posted. I'm making an online practice respiration quiz today. Do it online for practice. Practice means not a grade. All right, Georgia, I can't, if you can see this. All right. So again, this is all fermentation, and whether it's animal versus bacteria or fungus. This is all I need you to know for fermentation. Purpose is to recycle NAD, make ATP. Purpose here is to release CO2 and make alcohol. Okay, that's all that's going on there. All right. That's it for the Krebs. And that's it for fermentation. Like, all we have to do tomorrow is the ETC. I'm telling you, respiration is so much easier. So much easier for y'all because it makes more sense to y'all now. Okay. So what would be beneficial for y'all? Obviously, I feel like photosynthesis is always the one that's the hardest. Guys, y'all need to kind of just draw it out. Do your charts, compare and contrast between photosynthesis and respiration. Write out the where they take place, the use and the make, kind of like your chart. But if you kind of do it all from memory, then that's actually a good study technique for you. Tomorrow we look at the ETC, which is just like the ETC for a plant, but backwards, guys. This whole thing has been mirror images of photosynthesis. We ended with glucose in photosynthesis. Here we started with it. Glucose then releases CO2. It helped mate it in photosynthesis. Here we're making energy from the Krebs cycle, not using energy like the Calvin cycle did. Okay. Practice sites for photosynthesis respiration. I do have a few that I can just link onto Canvas whenever I post the Bozeman. I'll post your Bozeman. I'll post your quizzes. And yeah, if there's any other practice sites, then yeah, I'll post something there as well. But definitely, guys, I opened up your practice quiz and I'm giving you 3 attempts before it shows you the answers. So you got to go through it 3 times before you get shown all the answers for the questions that you have. Okay. I only put it as 10 questions, but look at other people's because I pulled from my question bank I created. So you're only getting 10 questions, but there's like 20 in the bank. So you might get 1 through 10, but somebody else got 11 through 20, so like, or 10 through 20, whatever. Anyways. So kind of compare y'all's practice quizzes to each other. I think that'd actually be good for the rest of the class since y'all still have like 15 minutes. I'm going to text Miss Whitworth right now so she knows. You have about 15 minutes of class. So what I do want you to do is go ahead and go onto Canvas and go ahead and look at that practice photosynthesis quiz, 10 questions, start looking at it, go through it until you get the answers. Okay. Alrighty. I'll post what I can find, Kate. All right. Bye guys.